How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 20.3 voltaic cells. So our objectives will be to describe the structure of a voltaic cell and explain what is occurring at an atomic level, as well as why it is occurring. So here we have kind of an example voltaic cell where we have an anode, we have a cathode, we have the salt bridge, we have the load, the thing that is being powered by the voltaic cell. And so let's get into it. In a voltaic cell, electrons flow from the blank to the blank. So it's always from the anode to the cathode, always in everything. Anode is where oxidation is occurring, and that's where you are losing electrons. The cathode is where reduction is occurring, and that's where electrons are being gained. So in order to gain electrons, they first must be lost. So electrons always flow from the anode to the cathode. A little mnemonic is like an-ox and then red cat. So anode is oxidation, reduction happens at the cathode. All right, which could take place at the anode of an electrochemical cell. So anode, again, I'm looking for something where there's oxidation. So I'm looking for electrons being lost, which is going to mean that the charge is going to become more positive. It's going to go up. So it could go from like a -2 to a -1 because that's becoming more positive or less negative. Or it could go from a +1 to a +2. It's headed in that direction. That's a 2, believe it or not. So let's take a look. What's going on? Well, F2 starts with a charge of 0. If it's not listed, it's neutral. And then it goes to -1. So that's definitely a reduction. The charge was reduced. O2 to H2O. All right, well, oxygen, just an element by itself, is 0. Oxygen in this compound has a -2 charge, so that's also reduction. Well, let's take a look. Cr2O7 -2. So I'm going to have to figure out the charge on the chromium. So I know each oxygen's -2, and there's 7 of them, so I have a -14. Overall, I have a -2, so there must be a +12 charge from the 2 CRs, which tells me I have a +6 charge on each of them. I go from a +6 to a +2, which means my charge was reduced. So it's not going to be that option either. Well, let's see, HAsO2 to AS. So HAsO2, let's see, each oxygen's -2, so I have a -4 from them. Overall, there is no charge. The hydrogen is going to be +1, so the AS must be a +3. And then if it's all by itself, its charge is 0, so this is also reduction. So none of these would occur at the anode. All of these are reduction. That'll happen at the cathode. The purpose of a salt bridge in an electrochemical cell is to do what? It allows charge to flow. So I'm going to go back to that first slide where I have a picture. So what's happening? All right, well, the anode is losing electrons. So the electrons are flowing from anode to cathode, which means we're going to have a buildup of negative charge here. And since we're losing electrons over here, it's going to become positive. Well, what happens? Can I send more negatively charged electrons into an area that is becoming more and more negatively charged? No, they're going to repel. So this whole flow is going to stop unless we have a way to let the charges flow after that. So here we have electrons flowing. The salt bridge is where ions can flow. It's not going to be the electrons flowing. It's going to be, hey, negatively charged negatively charged ions, the anions, can flow from the cathode to the anode, and the positively charged cations can flow from the anode to the cathode so that the charges remain neutral. If you didn't have a salt bridge, the electrons would stop flowing because they're going to be attracted to the anode that's become positive because they're negative, and they're going to be repelled from the cathode that had become negative from the other electrons going there. All right, number 4, what is the half reaction occurring at the cathode in a balanced reaction shown below? So cathode, again, you should think reduction. So we're looking for where electrons are being gained and charge is going down. So we were going to have to take a look at what's happening to all these species in the equation. So MnO4-, each oxygen's -2. There's 4 of them, so I have -8. the whole thing has to equal -1. That tells me there must be a +7 from, hey, there's only one Mn, so it's a +7. And I can see right over here that it drops down to a +2. So now I got to figure out, all right, what is the actual half reaction? So I go, all right, MnO4 minus becomes Mn plus 2. So remember the whole process of balancing half reactions. You go, all right, balance everything that's not hydrogen and oxygen. Check. There's one Mn on each side. All right, balance the oxygens by adding H2O. Well, there's 4 on the left, so I'm going to have to add 4 H2O on the right. All right, now balance the hydrogens. Well, now I have a total of 8 on the right, so I got to add 8 H pluses on the left, and now balance the charge. Well, on the left side, I have 8 pluses and a minus, so I have a +7, and on the right side, I have a +2. All right, so I got to add electrons, and I got to somehow, well, let's see, electrons reduce the charge, so I got to bring the +7 down to a +2. How am I going to do that? I'm going to add 5 electrons to the left side, and now my charges are balanced as well. And that's how you do that. All right, I hope you found it helpful. I'll see you in class. Okay, bye.